In 2026, water districts are looking at their infrastructure and making a massive choice: upgrade legacy SCADA systems or pivot to an IoT-based monitoring network. Here's a real-world scenario. On the left, SCADA quotes 12.5 million pesos for the system and support. On the right, IIoT quotes 2.1 million pesos for a system monitoring more points at a higher frequency. Both systems are legitimate. Both deliver operational value, but they are completely different architectures. Replicating what worked in 2015 without evaluating the tech landscape of 2026 is a 10 million peso error in judgment. SCADA has been the standard for water utility automation for 40 years. It works. Generations of engineers trust it. The vendor ecosystem is deeply entrenched, and funding bodies know exactly how to evaluate it. But the infrastructure math has changed. Back in 2010, connecting a remote pump station meant buying expensive proprietary radio modems. Today, every remote pump station sits under a 4G LTE umbrella. Sending sensor data to a cloud platform via cellular networks costs a fraction of what those legacy radio links demanded. The main issue utilities face today is institutional inertia. Procurement has standard SCADA line items. Consultants automatically specify it. The decision often defaults to SCADA simply because it is familiar, not because the engineering actually requires it. For massive treatment plants with complex operations, SCADA is exactly what you need. But defaulting to that same expensive infrastructure just to monitor basic distribution networks is a tremendous, unnecessary drain on your capital. Let's look at exactly what SCADA is engineered to do. Supervisory control and data acquisition was built for one primary function: near real-time supervisory control over distributed industrial processes. When you are running a water treatment plant with hazardous chemical dosing and strict filtration sequencing, operators have to intervene the second a parameter drifts. Real-time, deterministic control is non-negotiable here. This diagram illustrates a classic SCADA automated loop. A level sensor drops below a specific mark. The system processes that input and sends a deterministic command to start a remote pump. It is predictable, audited, and immediate. This precise timing is why SCADA is mandatory in high-availability environments. If a control failure at a chemical facility or a high-service reservoir serving a hospital creates an immediate safety hazard, you need that ironclad reliability. The steep infrastructure costs of SCADA are entirely justified by this fail-safe redundancy. When lives and critical operations depend on split-second control, you pay for the certainty. Industrial Internet of Things, or IIoT, serves a different primary function. It is designed for widespread monitoring, deep analytics, and gathering operational intelligence across a vast area. In IIoT, field sensors pass data through a 4G gateway to an MQTT broker and cloud dashboard. The hardware cost difference is staggering. This gateway costs 20 to 40,000 pesos per site. A legacy SCADA RTU runs 150 to 400,000. Because of that modern cellular architecture, IIoT can ingest 1-second interval data from hundreds of points simultaneously. Legacy SCADA historians typically struggle with that high-frequency volume, defaulting to much slower polling intervals. Cloud-based IIoT platforms also integrate machine learning natively. You get automated non-revenue water trend analysis and instant anomaly detection built right in, rather than needing heavy custom development on a legacy historian. Your district manager can pull up these modern browser-based dashboards right on their phone from anywhere.
Traditional SCADA usually forces operators through a clunky VPN access process just to see network status. If your goal is geographically widespread network monitoring and extracting real insights from your data, IIoT delivers vastly superior analytical functionality while stripping millions of pesos out of your hardware budget. But IIoT has strict limitations, and ignoring them is dangerous. First, cellular networks introduce variable latency, usually 50 to 500 milliseconds. If you need a pump to start in a split second to prevent a reservoir overflow, that cellular delay is unacceptable. Second, you are entirely reliant on telecom carriers. If your assets are in deep valleys or remote areas with weak cell signals, you cannot guarantee the connection. SCADA's licensed radio networks bypass that problem. Third, IIoT platforms lack the specific functional safety validations required for critical emergency shutdowns, like stopping a chemical overdose. Established SCADA platforms have decades of safety certifications backing them up. Finally, there is the reality of procurement. Government review boards and funding agencies know SCADA inside and out. Proposing an IIoT architecture usually demands heavier initial justification to get the required approvals. Treating an IIoT platform as a blanket one-to-one replacement for SCADA across your entire utility introduces severe regulatory and safety risks. You have to acknowledge where the technology stops working. The smartest utilities aren't choosing between SCADA and IIoT for their entire operation. They are mapping the specific tool to the specific application. SCADA owns real-time control, safety instrumented systems, areas with poor cell coverage, and environments with strict regulatory mandates. IIoT owns the territory of pure monitoring, high-frequency data collection, constrained budgets, and situations where field teams need priority mobile access. This diagram shows the resulting hybrid architecture. SCADA stays locked to the treatment plant for safety, while IIoT nodes sped across the vast distribution network. Both systems then integrate. Data from both flow upwards, feeding into a single, unified cloud dashboard for your operators. This hybrid approach is the standard for modernized utilities globally. You maximize life safety at the core of your operations, and you achieve affordable, total visibility out at the edges. When you take this recommendation to your board, evaluate it across 5 dimensions: functionality, coverage, scalability, staff capability, and your 10-year total cost of ownership. This chart tracks the 10-year total cost of ownership for a standard 40-site monitoring project. The SCADA system exhibits steep linear growth, ending between 28 to 45 million pesos. The IIoT approach stays relatively flat, landing between 5 to 9 million pesos. The on-the-money, IIoT interfaces work like standard smartphone apps. Your operations team can run them without the highly specialized, expensive IT training required to maintain a legacy SCADA system. Your next step is to map your district's needs into 2 columns. List your strict control functions in one and your pure monitoring functions in the other. The proportions of your capital budget should accurately reflect the size of those columns. Next week, we wrap up our water series by breaking down the financial calculation every utility board needs to see: the true annual cost of non-revenue water and how to prove ROI of a reduction program. Choosing the right tool for the right job is the single most powerful decision you can make in infrastructure management. Subscribe, and we'll see you next week.